sorry, I got you. It's a little weird, but I'm not gonna like throw up. It's like
Everything, but see, everything this week is you see. So anything that's like this, you have to
All right, guys, are there any questions on any of the assignments thus far? So we are going to finish chapter 6 up this week. So today we're doing 6.62, tomorrow is 6.63, and Wednesday is the last section of chapter 6, which will be 6.64, which will wrap up this chapter. Now, all of 6.6 is going to be dealing with solving different setups of these exponential and logarithmic equations. Now, everything we did on Friday was either dealing with kind of a one-to-one. Kind of a basic example is this here, 2 to the x equals 2 to the 8. If the bases are the same, we set the exponents equal to each other. And part of the reason that we can do this is dealing with, say, log base 2, applying it to both sides. And the reason that this works the way it does is because if we have an exponent inside of a logarithm, we can move them to the front, which will just tell us that we have x log base 2 of 2 is equal to 8 times log base 2 of 2. And one of the properties that we covered is whenever the base and what's inside the logarithm are the same, it simplifies to 1. So really what this is saying is that we have x times 1 is equal to 8 times 1, or x is equal to 8. It simplifies out. That's why if the bases are the same, the exponents have to be also. We're using this property here. Or with logarithms, the natural log of 3 is equal to the natural log of x. Well, here, the base is e, because whenever we have the base to a natural log of the base where they are the same, they simplify out. The fact that these will cancel out, leaving us with 3 equals x, which we covered on Friday. If the logs are the same, what's inside the logs have to be equal as well. That's why this works, is because we can apply a base to both sides to simplify the logs or natural logs and solve. Now what we're starting today is this one here, we can't write the bases the same. There's no way I can write 7 as 2 to a power. It just doesn't work. So what we have to do is apply logarithms to both sides. We have to apply logs to both sides of the equation. And more specifically, we're going to apply log base 2. Because when we look at this here, we have 2 to the x and 7. And what we're wanting to do and what we're wanting to try to do is to simplify whatever side has the variable in the exponent. And for this here would be 2. Now at this point here, we can move the x out front, telling us that we have x log base 2 of 2 is equal to log base 2 of 7. Now log base 2 of 2 would simplify to what? Well, 1. Whenever the base and what's inside the same, this here simplifies to 1, which really just leaves us with x. So if we pull the calculator up, so log, math, almost, log base, so if we do 2 of 2 and hit enter, we get 1, which is helpful because that tells us this is 1 leaving us with x. Now on the other side we have log base 2 of 7. So I'm going to pull this back down and type, so log base 2 of 7, if we hit enter, we get 2.807354922. It's not a nice number. It's not a rational number. So x is approximately 2.807, or we can say log base 2 of 7. Either one of these here is the correct answer for this. Questions on this here? All right, let's look at the next one. 3 to the x equals 8. So we're wanting to solve for the value of x. And again, just like the last one, we're going to need to use logs. So what log are we going to apply to both sides? Log base 3 of our 3 to the x and 8. Well, according to our power property, the x can come out front, telling us that we have x times log base 3 of 3 equals log base 3 of 8. Well, log base 3 of 3 is just 1, so we get log x is equal to log base 3 of 8. And unless it's asking us to approximate, that there is the answer. And in the calculator, we can say math log base 3 of 8, and we get 1.8927. And on the homework, you'll want to evaluate these to 3 decimal places. So 1.893. Questions on any of this here? All right, let's look at the next one. So what would we need to do first to solve for the value of x? Yes, I'd apply log base 7 to both sides. Because here, well, the 9x will move out front, telling us that we have 9x log base 7 of 7 equals log base 7 of 15. Now we do know whenever the base and what's inside are the same, it's going to simplify to 1, telling us that we have 9x equals log base 7 of 15. Have we solved for the value of x? No, what do we need to do next? By? Because we still need to get x by itself. Because 9x divided by 9 is just going to give us x equals log base 7 of 15 over 9. Because log base 7 of 15 is just a number. So we can divide it by 9. So in the graphing calculator, well, we can go alpha y equals enter to get our fraction. Go math log base 7 of 15 over 9. Hit enter and we get 0.155. And we can type it in at this point. So here, x is approximately 0.155. And that's it. That's all we need to do for these here. Any questions over anything we've done so far? Now, whenever we type this in, it's going to be good to wait to the very end to type it in. Because is log base 7 of 15 a nice number? Well, most likely not. because it's going to be an ugly decimal. Most of these will be. So it's going to be good to wait to the very end to type everything in all at once so we're not having to approximate multiple times over. Questions on any of this here? Let's look at this one here. We have 5 to the 3x plus 7 equals 311. So what can we do first? Right, we can apply log base 5 to both sides. And when we apply log base 5 to both sides, the 3x plus 7 is going to come out front. That's our power property. Anytime we have something to a power inside of a log, the exponent can go out front. What do we know about log base 5 of 5? It's going to cancel out. It's going to become 1. It's going to go away, yes? Okay. Go away. What can we do next? Subtract 7 from both sides. So here we have 3x equals log base 5 of what? It's going to be still 311. Because again, what's inside that log is being affected with it. We applied the log to 311, not to that negative 7. So it's going to be log base 5 of 311 minus 7. Is x by itself? No, we need to do what? Divide both sides by 3 to tell us that x is log base 5 of 311 minus 7 divided by 3. And if we type this into the calculator, what do we get? It should be a decently significant number.
Negative 1.141.
Negative 1.
Negative 1.445553.
445? Yep. And that looks right. And that'd be it. Now, again, we can have negative numbers in an exponent. Having a negative number in an exponent is perfectly fine. We cannot have 0 or a negative inside of a log as the final number. Any questions on any of this here? Is this as challenging as y'all thought this was going to be? No. Are you ready for the next one? Well, any questions on how we did these here? Because this here isn't any different than what we just did, is it? No. If we feel comfortable with these, we'll move on to this. If we feel comfortable with these types of problems, we'll move on to this one here. Now, we could have done problems like this with the previous ones, but here they normally use this with E. Now, before we can start applying the logs, or here it would be natural log, because that's how we undo E, we need it by itself. We need E by itself. And looking at this problem here, 4e to the negative 0.3x minus 7 equals 13, what's the first thing we can do to get E by itself? We can add 7 to both sides. Yes. Which will tell us that we have 4e to the negative 0.3x equals 20. Is E by itself? No. So what do we need to do next? Both sides by 4. And if we divide both sides by 4, well, here we'll have e to the negative 0.3x equals 5. Now to undo e, we don't just use any log, we use the natural log. So ln of e to the negative 0.3x equals ln of 5. Because the natural log of e reduces to 1, and we can move the exponent out front. So the exponent moves out front. This simplifies to 1, telling us that negative 0.3x is equal to the natural log of 5. So we have these here where there's other numbers written around whatever variable we have to the exponent. We want to try to get that variable or number by itself first. Because when we apply log to both sides, we really just want one term on either side as best we can. Now the next and last thing to get e by itself, well not e, x by itself, is going to divide both sides by negative 0.3. Tells us x is equal to the natural log of 5 over negative 0.3. Now luckily this one here is nicer to type into the calculator because natural log is just our ln button. So we can go alpha y equals enter to get our fraction, ln of 5 over negative 0.3, enter, and we get negative 5.365. Any questions on any of this here? Now with a lot of these here, they don't throw it so much with our numbers like the ones we had before, but whenever we're using this property or doing this, we really want to get a base is equal to a base. We want one thing on either side before we start applying the natural log. Now they're not always going to be the same, so we can say this is capital B, but 1 and 1. We want one on each side before we apply the natural log or logs. Any questions on any of this here? Let's look at this one here. 3 to the x minus 4 equals 8. So what can we do first? Add 4. Because we're really just solving for e. We're trying to get e by itself. So that'll tell us 3e to the x equals 12. What would we do next? Divide by 3 to get e by itself, which will tell us that e to the x equals 4. What would we do next? We apply ln to both sides. Ln of e to the x equals ln of 4. Well, the exponent is going to move out front. Right, ln of e is 1, so the x is by itself equals ln of 4. And that's it. Questions on any of this here? We kind of like this here. Do we need to see another example of one of these? Because the only way that this is any different than the one we had before is that we're going to have stuff outside the log. Because here e is already by itself, so we would start out with applying the natural log to both sides, which is just going to tell us that 4x minus 3 is equal to ln of 19. Then we would add 3 to both sides, telling us that 4x equals the natural log of 19 plus 3. Divide by 4, telling us that x is equal to the natural log of 19 plus 3 divided by 4. That's the only real difference between this one and the last one. Not too much change, it's just we get a little bit more to type into the calculator. Any questions on any of this here? We're ready for the next one. So here we're looking at log base 2 of 5x minus 17 is equal to 3. Now this one here is a little bit different because this time we're starting with a logarithm, not an exponential. But what we can do for this here is put these both to a base of 2. Because one of our properties that we had was b to the log base b of x is equal to x. Those will simplify out. Those will cancel out. And again, just like with exponents, whenever we apply this, it's good to have one term on either side. One term on either side. So the logarithm is going to be completely by itself. Because here, 2 to the log base 2 cancels out, leaving us with 5x minus 17 is equal to. On the other side, we have what? 2 to the third power. And what is 2 to the third? 8. Because 2 squared is 4, times 2 again is 8. So 2 to the third is 8. Any questions on how we got to this point here? It's all for x. So the first thing we can do is add 17 to both sides. And if we add 17 to both sides, we will get that 5x equals, and last but not least, we need to divide both sides by 5, telling us x And on these here, we do need to be careful because what's inside the logarithm cannot be 0 or negative. What's inside a log cannot be 0 or negative. So if we look back at this here, so log base 2 of 5 times 5 minus 17 is equal to 3. Well, 5 times 5 is 25. 25 minus 17 is 8. Is 8 negative or 0? Well, no. So after we plug it in and simplify all the way down, that number cannot be negative or 0. It's not so much that x is negative or 0, but once we finish plugging it back in, if whatever's in there is negative or 0, it doesn't work. It does not work. And whenever we check it, we're not checking anything that comes after the first one. We're looking back at the original problem. Any other questions on any of this here? Okay. Solve log base 3 of 10x minus 9 is equal to 4. What can we do first? Right, put both sides to the base of 3. So we have 3 to the log base 3 of 10x minus 9 equals 3 to the 4th. Luckily, log base 3 to the log base 3 simplifies out, just leaving us what's inside, which is 10x minus 9. 3 to the 4th is 81. Now we need to just solve. Questions on any of this here? Well, the first thing we can do is add 9 to both sides, which tells us that 10x is equal to 90. Divide both sides by 10, and x is equal to 9. And if we plug that back in, we'll see that what's inside the log is not negative or 0, and 9 is the correct answer. questions on any of this here? Are you ready for the next one? Do we need to see another example of one of these here? Okay. Okay. Now, just like with exponents, moving them out front, we use the power property. We can use another one of the logarithmic properties. Whenever I have two logs, two of the same logs added together, we can rewrite it as one log with what's inside being what? Multiplied. Because whenever we have multiple logs being added together, same logs, we can multiply what's inside the logs. So log of 2x plus log of x minus 5 can be rewritten as log of 2x times x minus 5. Now what can we do to simplify that log? Put both sides to the base of. Whenever the base is not written for log, log, it's understood to be 10. Natural log, it's understood to be e. ln is e, log is 10. As 10 to the log base, it doesn't say it, 10 simplifies out, cancels out, leaving us with 2x times x minus 5 is equal to 10 squared, 100. So now we just need to solve this here. So on the left-hand side, it's going to be good to multiply those together. 2x times x is going to be squared minus 2x times negative 5 is negative 10x equals, well, we do have a variable with a power greater than 1, yes, which means we need to get everything on the same side and get this equal to 0. Because what we have here is a quadratic. This tells us that we have 2x squared minus 10x minus 100 is equal to 0. And we need to solve this quadratic. There's many different ways we can solve it. One of them is to factor. We can solve it by the quadratic formula, or we can graph it. Which one do we want to do? So if we factor this, normally we don't have a greatest common factor, but do we have one here? Yes. We can either do one of two things, because since we're factoring out a number, we're not factoring out a variable. I can just divide everything by 2. Because since there's just a number out front, it's not affecting the answers. So really what we have is x squared minus 5x minus 50 is equal to 0. This is what we're trying to factor. And when we look at this here, two sets of parentheses. Since the 50, the third term, is negative, our signs are opposite. One's positive, one's negative. Our factors of x squared are, well, x and x. Now we need to look through the numerous factors of 50. Well, we have 1 and 50, 2 and 25, 3 doesn't work, 4 doesn't work, 5 and 10, and I believe that's it. So which ones would we want? 5 and 10. Which one would be positive? And 10 would be. So those would be our factors, x plus 5 times x minus 10. Now whenever we have one or more things multiplied together to equal 0, one of them has to be 0. So either x plus 5 is 0 or x minus 10 is 0. Here we would subtract 5 from both sides, telling us x is equal to negative 5. Here we would add 10 to both sides, telling us x is equal to 10. Any questions on this here? Now this one here is one we do need to check. Because what we started out with is log of 2x plus log of x minus 5 is equal to 2, yes? And what's inside the logarithms cannot be negative or 0. And we're not looking at it when they're multiplied together. We're looking at the original problem. So if we start off with negative 5, we'll have log of 2 times negative 5 plus log of negative 5 minus 5 equals 2. Well, that'd give me log of negative 10 plus log of negative 10 is equal to 2. Will this work? No, because there's two different places I do have a negative. So this here, x cannot be negative 5. We just can't have it being a negative. Now if we looked at 10, log of 2 times 10 plus log of 10 minus 5 equals 2. Well, here we'd have log of 20 plus log of 5 is equal to 2. Okay, 20 and 5 are both positive. This should work. And if I wanted to, I can grab the calculator and say log of 20 plus log of 5 and hit enter, and it does give me 2. So this one here works. So here x equals 10 is the answer. X minus 5 does not work because it does give us negatives inside the log. Any questions on this here? Thank you. We ready for the next one? We'll do this one here and then we'll move on because I think one more of these here and we'll probably have it. We'll see. Well, how would we start out with this? We would rewrite this as times equals 2. Because whenever we have two exact same logs, where log and the base are the same, we can rewrite it as 1, where what's inside is being multiplied. Six, because they did write a 6 in. Now log base 6 of 6, this here is gone, really gone, leaving us with 6x times 6. Now on the left-hand side, we can multiply this through. So 6x times x is 6x squared. 6x times negative 1 would be negative 6x is equal to 36. Now again, we have a quadratic, so we need to get this thing equal to 0. So we can subtract 36 from both sides, which tells us that 6x squared minus 6x minus 36 is equal to 0, yes? Now we can factor this if we want. I'm going to do it a little bit differently. I'm going to pull up the graphing calculator. Clear. So 6x squared minus 6x minus 36 is our quadratic function, yes? And we're trying to see what values of x make this equal 0. So I can go over to the table and see one of the values of x would be 3. And the other is So I just used the graph to see what values of x makes the y value 0, which is negative 2 and 3. So over here, x is equal to negative 2 and x is equal to 3. Most likely, which one's not going to work? Negative 2. And the reason we can say that is because if we look back at the original problem, which is our log base 6 of, I think it's 6x, plus log base 6 of x minus 1 is equal to 2, is with our 6x and x minus 1, is there anywhere in there to counteract that negative if it was negative 2? Well, no. There's no squares. There's nothing to make it positive. So that one's not going to work. It's leaving us with x is equal to 3. Any questions on this here? Any questions on everything we've done so far? Do we need to see another example of one of these? This one here is not any different. This here is the last thing we're going to look at. Now, with exponents, exponent can be positive or negative. So what we're doing here really doesn't change too much. Now, if this had been equal to, what would we have applied to both sides? Log base 3. We'll do the same thing here. Because here, log base 3 of 3 simplifies to 1, leaving us with just x. So we're saying x is less than log base 3 of 20, yes? I mean, we can approximate it as a decimal, but that's it. The only time that we have an issue with these here is if we get something where we can't have it be negative or 0. So when we start talking about logarithms. What would we do for this one here? Questions on this here? We ready for the next one? I think we're good with these here, yes? Because this is, I mean, it's quote unquote different, but the only thing that's different for this here is that we're going to have to solve for x after we apply the log. Because if we work this all the way through, we would see that x is greater than log of 3 plus 6 over 2. We would get to this here. Because that's the only difference, is we're having to do more than just applying the log to get to the answer. We would actually just need to solve for x. 2x minus 6. So to get the 6 away from x, we would add it. And then to finally get x by itself, we would divide by 2. Does that make sense? It gets daunting when I just throw numbers up there like that. But all we're doing is solving it out. Does anybody need to see this one? We good, Paris? Yeah. Okay. These here is when we do need to be careful. Because what we said is inside this logarithm cannot be what? 0 or negative. So what we're saying, and this is kind of we can have off to the side, is that x has to be greater than 0. Now, sometimes we'll have to do a little bit more than just this, because if it was x plus 2 inside the log, we'd have to set x plus 2 is greater than 0 and solve for that value of x. But luckily for us here, it's just saying that x is greater than 0. Now, what are we going to apply to both sides? We're going to put both to the base of 10, because 10 to the log base 10 of x. This here cancels out, telling us that x is less than or equal to what? 10 squared, which is 100. Is 0 a possible solution for this here? Is 0 less than 100? Yes. So could 0 work for this here? Yeah, any negative number would also work, yes? But what do we know? X cannot be 0 or less than it. So what we have to add is that X has to be greater than 0. That's why we did this at the start. Because with any of these logs, if 0 or a negative is contained in the solution set of what's going to make whatever's inside the log be that, we have to add that restriction. Because here, X cannot be 0. But 0 is less than 100, yes? So we add that in. If it had said X is greater than or equal to 100, we don't have to worry about it because 0 is not less or not greater than 100. So this here is the solution. Any questions on this here? They didn't specifically write it, but this is what we're looking at. And this is the last one we'll look at today. So the first thing we can do is find from both sides, telling us that log of X is less than we would put both sides to the 10th power, telling us X is less than 10 to the 36. We're going to leave it as that because that number is massive. That number is massive. That is undectillion. But is 0 less than that big number? And since X is by itself, we're just going to add 0 is less than X is less than 10 to the 36th. And that's it. Any other questions on any of this here? On page 340, we have these here. We will do some more with these inequalities and properties of logs over the next 2 days. That's why I'm simplifying and breaking it up. So we can dig a little bit deeper into this here. And once you get finished writing that assignment, y'all can go on to your next class